About exponential versus linear functions. So you're going to be able to compare their properties and be able to tell me if they're linear or exponential, and we can kind of talk about their domains and stuff like that too. So, how do you identify exponential or linear from a table? First of all, how do you know it's exponential from a table? So, from a table, you look for constant multiplication of the same number. So from a table, you're going to look for that constant multiplication of the same number. If it's exponential growth, your b in y equals ab to the x will be bigger than 1. So the number you are multiplying by will be bigger than 1. Remember, that's your multiplier. If you're looking for exponential decay, your b value will be between 0 and 1. So you'll notice on that first table, what is our b value? What is our multiplier?
-5. No, that's second one. 4.
You are multiplying by 4 each time. So since you are multiplying by the same number as x goes up, why did I put 4, 4, 5? It's crazy how things happen sometimes. Since it's multiplying, it's exponential, and since 4 is greater than 1, it is exponential growth. So that's why this one is exponential growth. Exponential decay, what is that table multiplying by, RC?
5, 1/5.
Yeah. If you guys don't remember you could have taken like 4 over 5 divided by 4, and that helps you find it. Do not talk about the division. It is always multiplication. So since this one is 1/5, it is between 0 and 1, and it is multiplying. It is exponential decay. Okay, questions on determining exponential growth or exponential decay? Get that written down, and then we'll move on to the next slide. What?
What is that under,
And, yeah.
Okay.
Schedule, does that mean like this is one day, this is the next?
Yeah, so this is the 18th, Monday the 18th, Tuesday the 19th, Wednesday the 20th, you have 1 through 6, your final and 7th hour. Thursday the 21st, you have the 1st, 2nd, and 3rd hour finals. You don't have these classes, so these should have X's. I guess this is so you can still study it. You won't be in these classes that day, but you're done with this class. And then on the last day, you have these finals. Okay. All right, how to identify an exponent or a linear from a table? You look for constant addition. So you look for a constant rate of change, which is constant addition or subtraction. Okay, guys, you have a test next week, and I don't know how some of you are going to do on it, because you will not focus. Let's get focused. Where are we going? Why? In a second, I'll write you a pass, okay? Just let me get through this slide, okay? Okay. Shh. Please stop talking. This is the next page on the top. Just be nice to each other, please. Okay, so you'll notice that if it's a positive linear, it will be adding the same number. So what is this positive linear adding?
5.
So we have a slope of 5. So it's positive. So it's adding the same number, so it is positive. If it is a negative linear, it will be subtracting the same number, so it will be negative. What is my slope for this one?
Subtracting 2.
Yep.
Good job, Mike.
So your m value is negative 2, which makes it a negative linear. Okay, look at those. Do you have questions on determining exponential or linear from tables? Guys? No. Mike?
What? I didn't even do anything.
All right. Is that away or else I'm going to take it? How do you know it's exponential from an equation? From an equation, you look for the variable to be the exponent. And that's typically x or t. T is for time. Like in the exponential growth or decay formula, it's a t.
Josh, don't look at me like that. Wait, T or what?
It's typically x or t. I'm not writing that down because it's not always that.
Oh.
That's why I put the variable. Hey guys, let's focus. You should be writing all of this down. Justin, you should be writing stuff down.
I wrote it.
Everything. All right, Mike, forward. Your elbow shouldn't even be on her desk. Get it off of her desk. So if it's exponential growth, you look for the b value to be greater than 1. Make sure you're actually looking at the b value, not the a value. A lot of you guys have been looking at the a value. What hour are you, Cameron? Were you not done? I thought you finished. Oh, you're just turning stuff into me. You finished your quiz, right?
Yes.
Okay. That's what I thought. I was like, I thought you graded it.
And then I just, you just gotta put your name in a note.
I don't know how many assignments you're missing, so. Oops. I don't know if you're missing anything right now, so I'm just going to do that.
I don't think I'm missing anything, and I'm almost done.
Okay. Stop. Oh, yeah, I need to write you a pass. I'm sorry. I'll do that in a second. All right. I forgot about that. So, what is my b value here? B equals 5, which is greater than 1. Brian, what is my b value on this one? And what is my b value on the last one?
1/4.
But it's not actually 1/4. Can we have negative exponents?
No, we shan't.
So that's actually 4 to the
First.
x, because a negative exponent means a reciprocal. So what is my base value?
4.
4, which is greater than 1. Okay, get that stuff written down. Stop. You guys are complimenting, which I appreciate, but the problem with this class is that it ends up getting out of hand real quick.
We compliment too much.
No. You guys turn it into something else.
I'm just saying things.
All right. For exponential decay, Mike, stop turning around. Get your arm off of Emma's desk. Okay. For exponential decay, y equals ab to the x power. B is between 0 and 1. What's wrong, Mike? The first one?
Yeah.
Okay, 1 second.
Trash can.
Okay, Mike, what is my base value on the first one? 1/2. And 1/2 is between 0 and 1. What is my base value, Jayla, for the next one? Which is greater than 0 but less than 1. What is my actual base value on that last one, Cassie? It's 1/2. We can't have negative exponents, so that reciprocates it. So your base value is what then? So it is 1/2, which is between 0 and 1. Good job. So, what questions do you guys have about exponential equations? Stop. We're doing all the slides. Guys, stop. What's wrong? In a second, just let's get through some notes. All right. How to identify exponential linears from an equation? You're going to be looking for a few things. You'll look for if it's in slope-intercept form, point-slope form, or standard form. If it's in any of those forms, it's good. Or you can look for x is raised to the first power. It means like it looks like there's no exponent. You're fine. Thank you. All right. So if it is a positive linear, okay, let's focus back up here. If it's a positive linear, m will be greater than 0. So first of all, what form is y equals x? Is that slope-intercept, point-slope? Is that standard form?
Point-slope. Slope-intercept. Oh, yeah, wait, yeah.
So this is slope-intercept. And what is, Mike, what is my m value?
The slope.
Yep. What is your slope, though?
What?
I want to know what the slope is in that.
No, what?
In y equals x.
1.
It is 1, which is greater than 0.
Oh, that was good. My bad.
What form is the next one in, Jana? Point slope. And what is my slope of that then? Your slope is 2. And 2 is greater than 0. What form is the last one in there, Alyssa? Can we see the slope in standard form? No, so I would subtract 2x and divide by -3. So what is my slope then, Alyssa? Which is greater than 0. Connor, forward. Stop turning around. Mike, with your elbow there, you're more apt to turn around. Get your elbow off of Emma's desk. So a negative linear. M is going to be less than 0. The first one is still in slope-intercept. What is my slope this time, Emma? Which is less than 0. Connor Clover, the next one is in point slope. What is my slope? We don't have to say x, we just say -2. And that is less than 0. And the last one is in standard form, and you cannot see your slope in standard form. You cannot see your slope in standard form. So you have to put it into slope-intercept form. What?
You guys used to use those desks?
I don't know. That was in this room when I moved into here. How long have I been in this one? 3 years. This is my 3rd year. So I spent 3 years in where Miss Deppin's room is, and then 3 years here. This is my 6th year teaching.
They're immature.
All right. So, what is my slope, Jordan? Okay, so M is -2/3, which is less than 0. Okay, you two and Josh need to stop. Do you understand me? Okay, questions on identifying linears. Okay, next thing will be graphs. So for graphs, you look for the J shape or the L shape. If you can find the growth or decay factor, because it's easy to see the numbers, you should use that too, but sometimes you can't see the numbers. So if it's exponential growth, it will be going upwards to the right. So it will form that J shape. If it's exponential decay, it will be going downwards to the right. Yes, Mike?
So that when it's saying which one is it, and then it explains it.
Yeah, and I'm going to explain a little bit more in just a second here. So you'll notice that you can see the ordered pairs on this one as well. So this is 1, 1, 2, 4, 3, 8. What is our multiplier on this one? Lexi? 1, 1. Oh, wait. That's not right. That's 1, 2. So it's 1, 2, 2, 4, 3, 8. It's counting by twos. So what is it multiplying by?
2.
Yeah, the outputs are being multiplied by 2. So 2 is also greater than 1. So that's another way you can look at it as well. The next one is 1, 50, 2, 25, and then 3, 12 and a half. So what is my multiplier on that one? I'll take it. Thank you. What'd you say? It would be 1/2, which is less than 1. So 1/2 is less than 1, so that one is, or between 0 and 1, so that one is decay. So do you guys see how you could look for 2 different ways to see if it's exponential growth or decay? Okay, lines. You just ask yourself, is it straight? If the line is straight, because that's the only way for it to be a line, then it is a line. Those of you that decided to tell me on the quiz, I crossed it off on your quiz when you were explaining why something was exponential growth or decay, and you said, the line is going upward. It's not a line. Exponentials are a curve. The only thing that is a line is something that is straight. Do you understand me? So positive linear means that it's going upwards to the right. Negative linear means it's going downwards to the right. I really don't think I need to explain anything else with these ones.
Why can't you put upward to the left?
Because we read books left to right in this country. We do not read them right to left. So we always look at things left to right. All right. Lastly, we're going to do some examples, and then you guys will get time to work. Determine linear exponential, and then state the slope and the growth factor. Thank you. Okay, please pay attention. Please pay attention. A. It is exponential. Why? So it's exponential growth. There's really no space to write. Upwards J, right? And then it says state the slope or the growth factor. What is this? What is the growth factor for this one? Looks like it's 1, 1, 2, 3, 3, 9. What would the growth factor be?
Times 3.
Times 3. Good. Okay, the next one. RC, is the next one exponential or linear?
Linear.
Linear, it has an exponent of 1. Can we see the slope yet? No, it's in standard form. So I'm going to get the slope by putting it into slope-intercept form.
Did it tell you to get this one?
State the slope or growth factor. So RC, what's my slope?
1/2.
So is this a positive or a negative linear?
Positive.
It's positive, and it's linear because the exponent is 1. Or it looks like there's no exponent. Because we don't have to put an exponent of 1. Okay, next one. Exponential or linear? Tanari. C. It's linear. Why? Right, but, I mean, exponentials go down as well. What makes this linear? It's a straight line. So it's a straight line, and is it positive or negative? It's negative because it's going down. What is my slope? What is my slope?
Straight down. No. 1 over. No. Yeah, 1.
No, 2 over 3. You have to choose exact points.
I can't even see.
But it's going downward, so it's negative 2/3. Brian.
Yeah.
What? 2, up 2, over 1, 2, 3. Down 2, over 3. This one's halfway between, so you can't use that one. All right, next one. Exponential or linear?
Exponential.
This one isn't even counting by the same number, so you have to be careful. Just be careful. You might be right that it's linear. So it's subtracting 8 and adding 4, right?
Yeah.
So, subtracting 6, adding 3, subtracting 8, adding 4. Does it have a constant rate of change? Negative 8 over 4 and negative 6 over 3 have a slope of?
Wait, 2.
It's negative 2. It's x. It's y over x. Y over x. Negative 8 over 4. Negative 2. Negative 6 over 3. Negative 2. Negative 8 over 4. Negative 2. So this is linear. Constant subtraction. E, is that linear or exponential? Exponential, is that growth or decay?
Growth.
So it's exponential because the variable is the exponent. Connor, pick your head up. Connor's like, I can't do anything right. Is that how you feel right now? Okay. So is it growth or decay?
Growth.
Growth. Your B value is 4/3. It's the number that's being raised, which is greater than 1.
You still cooking?
Huh?
Still cooking?
Cooking.
Okay, F. Shh. Stop. You guys are driving me insane. Just listen. All right. Let's see if this one is linear or exponential. It's adding 1, adding 1, adding 1, right? Is it adding the same thing on the y? Definitely not, right? So is it multiplying by the same thing on the y? How could you check it? What would you do? Could you do 9/2 over 3? So what's 9/2 over 3?
3 over 2.
Which is 1.5, right? If you do 3 divided by 2, that is 3 over 2, right? Do 2 over 4/3. What is that?
1/2.
Not 1/2, but 1.5, right? They're all 1.5. So, hey guys, again, a lot of you guys would have probably told me it was neither in this situation because you can't see it right away. Am I right?
Yeah.
You need to do the work, and some of you don't understand how to find it, and you're talking. Stop. So if you have an issue, just don't forget to divide backwards to see if it's all the same thing. Do we all understand that? So this is exponential what? Growth, because your B value is you're multiplying. So 1.5 is bigger than 1 is the reason there. Okay. Are there any other ones in there? Am I done? One more? 2 more? Okay. Well, whoever asked me to go back, let me know when you're ready. Okay, determine whether the function is linear or exponential. So we're going to verbally say that and just state the domain and range. So is this linear or exponential? Exponential. It's that downward curve. What is the domain of this exponential, Riley?
Isn't it infinite or infinity? Negative infinity?
Opposite way. You always do least to greatest. So negative infinity to infinity, or you could write all real numbers. Yeah, that's fine. What? Do you want to tell me my domain? Or do you have a question?
Oh, the range.
Or, okay, I'm sorry, I meant the range. What's the range?
Yes. Oh, it's 2 infinity.
It starts at the asymptote and it goes up forever, or you could say y is greater than 2. Okay. What does a linear look like? What does a linear look like? Because this is linear, it's in point slope form. So if I were to graph this, it's at -6, +3, goes down 1 over 2, down 1 over 2. So you'll notice it looks like this. What is the domain and range of a line that is oblique, meaning it's not a vertical or horizontal? It's not just infinity, it's negative to infinity. Doesn't it go left to right forever?
Yep.
How about the range? Does it go up and down forever?
What?
Up, down. So it's both are all real numbers. What happens in an x equals equation? Because this is linear. What happens in an x equals equation? What? What does x equal mean? No. It doesn't get flipped. That's inverse. This isn't an inverse.
Sorry, bud.
It's not a horizontal. No, I'm sorry. It's not a horizontal line, guys. It goes through the x-axis. The x-axis would create a vertical line. So what would your domain be for that? Because it's not going left to right forever. What is your domain?
4.
-4, right? It's always -4. So you'd either say x equals -4, or you'd use the set notation there. It should be -4 in both of those, sorry. And then what is my range? Does it go up and down forever? So that is all real numbers. Okay, finally. Describe in words the rule for each type of slope or growth factor. So what do you do with a slope of 3? What do you do with a slope of 3? Yeah.
Multiply x by 3.
It's slope. You're not multiplying.
Go up by 3.
It means up 3,
Over 1.
right 1, right? You're adding 3. What do you do with a b value of 3? You're multiplying outputs by 3. So which kind of sequence corresponds to 4 plus 3x? Which kind of sequence corresponds to linears? Riley, do you know, or were you raising your hand? What kind of sequence corresponds to linears? Is it arithmetic or geometric?
Arithmetic.
Arithmetic is the adding one. Guys, we did geometric the other day. What did we do each time in a geometric? We multiplied. So shouldn't that correspond to something that is multiplying?
Yeah.
So that is geometric. Okay, we're not going to do the table. You guys can figure that out on your own. Oops, I didn't mean to do that.